Okay. All right. Welcome to this session. The live interaction for this course on numerical methods and simulation techniques for scientists and engineers. Um, Please post your queries. This is one query. I am not too sure whether the person who asked this question is around, but by the end of the week, all the assignments will be checked and the marks will be uploaded. So you can check there. So each assignment will finally be rescaled to something different, but each assignment contains 100 marks, if that is the question that you're asking. So please post your question. Yes, if you are watching, please ask your questions. I'm waiting for questions. Yes, starting time is 3 p.m. Yes, Rosie. So central difference method is while you do the differentiation, so you can take difference between 2 points. Okay. So these 2 points could be the point at which you want to calculate the derivative, and the point which is on the left, or in other words, in another method you can have also a point on the right, and take the difference between the two, or calculate the value of the function at these 2 points where you want to calculate the derivative, and divide it by the distance between the 2 points, and try to get them as close to each other, so that in the limiting case that h, what we call it, goes to 0. So that's usual way of forward difference or backward difference. But in the central difference, you actually take 3 points and calculate the derivative for a value for a function at a given point. Okay. So that's where the central difference. So you take 3 points, or even it could mean that you can take a point on the left as well as on the right. So f of x plus a minus f of x minus a divided by 2a, say for example, limit in the limit 2a goes to 0. That's what is called as the central difference method. Okay. Usually central difference method has a slightly higher accuracy than the other methods. You're not, Purnima Jha, if you're not getting negative values, that is a concern for bisection method. Bisection method crucially depends on the value of the function changing sign, which means that it passes through 0. Okay, so on one value of the either the guess or the calculated value, it has a positive sign, and when you iterate this solution, it has a negative sign. So if it has a negative sign, then the root is bounded between the earlier value and the later value. So if you're not getting it, then there's a problem. Okay, so you have to iterate many times and in order to find the actual root. But if you still don't get it, which means that your guesses are very wrong, you need to revise your guesses and start doing it all over again. That's what it means. Okay. The 3-point formula simply tells you that you have to take 3 points in order to calculate the derivative, and divided difference means that, I mean, these have been, talked about in the classes. So please go through the lecture notes. You'll definitely get an answer to when we try to calculate derivatives. See, the 3-point formula is usually used for a double derivative, whereas the other methods, say forward or central difference or backward difference, they are for the single derivative. Okay? But you can also, for increasing the accuracy, you can use points which are you have to intelligently take your points where you want to calculate the slope. So you can tune your points and calculate the value of the function, and from there you can calculate the value of the slope or the derivative. All these methods for simple problems give rise to same result. Okay, when the function is not fluctuating very rapidly within the interval that you're talking about. Okay, all of them will give you the same result. However, like the central difference is expected to have a better accuracy. That is when you exactly want the slope to be calculated at a point with much greater accuracy than what you would have from any other this thing by say other methods, in the sense that you may want a 5-digit accuracy. So then some methods work better than other methods. Okay, but they ultimately, at the second decimal place or third decimal place, all of them should give you the correct same result. So regarding Purnima's question, the bisection method, that's why for root finding is not really the best method to resort to. You have Newton-Raphson method, which is more accurate, and because you don't need to enclose the roots between two guess values. So you just need 1 point, and then you need to calculate the slope. But then it also has the problem that that you lose on certain thing, because calculating slope numerically is a hazardous problem because of reasons that I have elaborately explained during the lectures. Because you divide by a very small number, so there is always a possibility that if that number becomes too small, you have a divergence. Okay. Rosie, the results will be declared by the end of the week. That's what the TAs have told, and they will post it on the site. So that should be done. They are not done with evaluating all the assignments, so they're just waiting. Please post your queries, further queries. You know, when I teach a method, it is also your duty to go and look for methods which are close by. Okay, because there are only limited amount of time that you get for these lectures, but the central difference method is nothing different than the forward or the backward difference, excepting for a very small change in its formula. So this you should have gone and looked at the central difference method. Not everything would be told. This is how we train our students, that that not everything is told, so the students, so that they are encouraged to go and find out things. That's how you learn better. If it's all about telling you all these formula and problems, then you become too dependent on the lectures. Um, so Purnima, the pattern of the exam will be solving questions and writing down the final answer. It will not be MCQ. You have to do what is known as fill in the blanks. But fill in the blanks will be after you solve a particular problem. Yes, Rosie, I agree with you that 3-point formula is also referred to as 2-point central difference. Yes. The final exam, because this is 8 credit, 8 weeks course, which means that 20 hours. The exam paper will be of 3 hours duration. Okay, and the each question will carry certain amount of marks, say for example 10 marks or 12 marks. So but they'll have parts, and all are from the concepts that have been told in the class. So if you practice the formula, practice the way things are, iterations, say for example, are done, then and they are mostly of the same type as the tutorial or the assignment questions. Okay, so if you do them independently, and uh, you should have the confidence in doing very well in the exam. And in any case, this course is about, it's not a core course, it's a course which is a prerequisite to many things, in the sense that you need numerical methods and simulation techniques for research. You need it for many of your solving problems which do not have an analytic solution. So that way, the course cannot get any, hard. I mean, it's not a difficult course, but you have to know the formula, you have to know how to apply it, you should know the all these runge kutta, methods. If you have come to that, if you haven't, then of course you have to wait till you come to that. But I believe that you've gone through all these Newton-Raphson, bisection, then Lagrange's interpolation formula, etc., etc. So all those things will be there. Pretty much the same way as you've written down the assignment, excepting that right now we are not interested in seeing the intermediate steps. Having said that, that's more risky, because if you make a mistake in some of the intermediate steps, then you'll not find or you'll not get the right answer for the final step, which is when do not get marks, or you get very little marks, because we don't know what steps you have gone through. Okay, so that way we are only asking for the total marks is like, we would finally mark it out of 100, just like any course. Okay, but right now things are all blown up, so that we have very large number of large number or large total marks, so that we can get a distinction between people, and the people who is also to make sure the more and more people pass in the course. So that way the total marks is scaled down marks, I can tell you, is 100, just like any other course. There is some formula, Rosie, that we follow, so that we can give you maximum benefit. So right now, each assignment will contain 100 marks, and then we'll scale it down, and something like 20-25% of the assignment will be taken, and the rest will be from the final exam. The passing mark is, I believe it's either 35 or 40. And so please do these things because you see there is a problem with if you do all the intermediate steps correctly, you should arrive at the final answer also correctly. However, if you miss one step, then the rest of the steps will give you wrong answer. So, in order to remedize that, we would look at your answer with some tolerance. Okay, tolerance means that suppose I have asked for 5 digits of accuracy, and somebody, of course, you get full marks if you get it exactly what the final answer should be. But suppose somebody hasn't done that or hasn't gotten that, we will be considering that. So marking will be lenient. You just have to perform as per your satisfaction. The exam will be offline. Offline. As I said that you'll have to work out everything, but you will not be given an MCQ and so on. So you'll have to write down things and finally write down the final answer. Okay. So it will be an offline exam. No, no, no. You have to write down the final answer, and the final answer cannot be written down on the computer. It will be a pen and paper. You need to do a lot of calculations, so make sure your calculator is available and so on. A lot of books actually cover Python. There is a book. I don't remember the name, but I'll ask the TAs to post the name of the book. Um, there's a very nice book and very easy to see. I think it's called Bytes of Python or something. BYTES. Yes, many books are there. There's an old book by Raja Raman that you can look at it. Then there are other books on numerical programming, many books actually. I'll still get the TAs to post name of some books. I'll do it quickly. Thank you, Shavni. Yeah, calculators are allowed. Derivative of a polynomial, definitely Newton-Raphson is the best method. Any polynomial, not only cubic polynomial. You just need to calculate, you just need a guess point to begin with and then calculate the slope at the point. From the formula, you calculate where the slope touches the x-axis. That is the new root, and from there you calculate the slope again and then get a new root yet again, and so on. You go ahead with this iterative procedure in order to find out um, this the root, this numerical solution of an equation. It's only solving type of questions for Numa. No definition of formula, etc. are not there. It's all only application of formulas by using different methods. Or there could be some physical problem in which you have to apply, say for example, Lagrange's polynomial method in order to interpolate the data. So those kind of things will be there. Yeah, I know you talked about numerical differentiation. So Newton-Raphson is the best method. Rosie. I don't know Shagnik, but I'll find out from the TAs. We'll evaluate all the assignments, and if we have this thing, then best 6 assignments can be taken. It's best that you ask this question on the portal so that the TAs can reply. The people who are involved in evaluation can reply. Thank you, Sharmi. Doesn't matter. I mean, in the sense that Newton-Raphson method applies to any function. Okay, so you have to, uh, if you have to find the derivative of a polynomial at some point, then you can plot the polynomial and can actually calculate the derivative using Newton-Raphson method at that particular point where it is asked for. Suppose this, the distance versus time varies in some manner, which is a cubic function of t. So x is a cubic function of t. Say 3t square plus 3t cube plus 4t square minus 5t plus 7. That's a cubic part of polynomial. Then if you want to calculate the velocity from this at a given time, say for example t equal to 10 seconds or t equal to 20 seconds, you just take a derivative of this at 10 or 20 by using this method. I mean, so you, oh, you mean to say, sorry, you were talking about a derivative. You talked about a derivative. I'm sorry, I was thinking of more like solving an equation. Yes, you're correct. It's not, we don't apply Newton-Raphson. Sorry, I was just, thinking more in terms of solving an equation. Yeah, so cubic polynomial, you use, as the function is very strongly fluctuating, which is a cubic function does, depending on how much is the coefficient of its cubic term, then you need to go for higher order derivatives. Okay, so I mean involving more and more points. Okay, so if you take 2 points which are fairly farther apart, the result that you get is very bad. Okay, so you need to take more points and calculate it at various places of that cubic polynomial, and you have to say that these are at um, uh, uh, basically the derivative of the function at different places. In exam, there will be 10 marks for each question. Yes, that's true. Finite divided difference, that should be the uh, best method among the ones that we have discussed. Yes, true. Thank you. Please ask your questions quickly. We have about 20 minutes left. Uh, we'll wait for a few more minutes. If there are no questions, we'll have to wind up. Wait till 3:45. So please do post your queries even after this one. We still have one more live session left for this. But if you face any problem, please do ask. Put it in the portal, and the TAs will be happy to answer. See, Rosie, it doesn't matter. Okay, I will not be able to answer your question unless you tell me where do you want to calculate the derivative. Okay, if you want to calculate a derivative where the function is fluctuating rapidly, then of course you need to go for higher order this derivative formula. Okay, so but if you are at a smooth place, even your x cube is at a smooth place. They have the the smooth regions where you can calculate the derivative using even forward difference formula and so on. Okay, so you can either it could be okay, but depending on how, if you are very close to the upturn, etc., or where the function is fluctuating, then you need to take more points. Where the function is smooth, then you can do it with any method you want. I can tell you only this. Yes, I understand that. I understand. But you calculate a derivative at a particular point. That point has to be, you can use a central difference that is that will be slightly better in this context. If you are asking that, I can tell you this. Okay. But in general, for a say a quartic polynomial, I mean with 4 power 4 and power 5 and all that, that's a little difficult to say unless you tell me the point at which you want to calculate. So you want it at very close to the origin, okay? So which means that the term that will dominate is the linear term. In which case, since you're very close to the origin, that is at x equal to 0, I would recommend that you use the forward difference formula. Or you can use the central difference also. They won't make too much of difference. So you can take a point which is on either side of x equal to 0.01, that's a 0.005 and 0.015. You can take these 2 points, whereas you can also take a point at 0.01 and 0.015 or 0.05 and 0.01, 0.005 and 0.01. See, why I did that is that at x equal to 0.01, The first two terms are negligible. They're very small. Okay. Uh, but the only dominant term is the 11x, which is a linear function. Okay. Uh, Orthogonal, I would not know that, but if you send an email to me, I can get you connected with a professor in chemical engineering who has written a book. His name is Professor Pallab Ghosh, using MATLAB. So, orthogonal collocation method, if that method is being taught, I would not know that. Thank you, Saurabh. Yes, you can do it. Yes. Yes, because you are very close to zero. At larger values of x, I would say that a divided difference method is probably more accurate. Welcome. Any other question? We are just a few minutes away from the end time. About 3 minutes remaining, 3 to 4 minutes. 3 minutes. Anyway, I'll have one more session with you. So anyway, we are running out of time. Just before we end, so please submit the assignments and carefully see all the formula that you need for implementing a topic, or rather a method for either taking a derivative or doing an integration or solving a differential equation, etc., etc. There'll be one question from each topic that are being taught, and the final exam, as I said, will be of 100 marks, and they will have equal distribution of marks for each question, and it'll so that it will fit into 3 hours of exam, and it will be offline. You'll have to write it, and you have to finally show us the final step that you get. Okay. If there are no more questions, we are going to wind up. It's almost time. Please do ask questions on the portal. The TAs will be most happy to answer them. And thank you very much. Please attend all the rest of the lectures that you have for this course. Sincerely, I wish you all the very best for this course and also for other things, career opportunities that you may be pursuing for each one of you. Thank you.